Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's the problem for today for exam MAS 1. You are given the following information. Consider a system of 3 independent components, each of which functions for an amount of time in months uniformly distributed over the interval from 0 to 1. Under current design, the system will fail if 2 of the 3 components fail. A new design was made such that the system will fail if all 3 components fail. Calculate the increase in expected system life in months under the new system design. And here's the solution. Let us write y sub c for the random life of the system under current design. Under the current design, the survival function of the system is the survival function of the second-order statistic of a random sample of size 3 from the uniform distribution on the interval 0, 1, which is S sub yc is the probability that second-order statistic is more than y, which is the probability that 2 or 3 pieces, I'm sorry, I need to say pieces in this, well, I'm not able to correct it right now, so my apologies, it should say pieces, of the random sample are more than y, which is the probability that 2 or 3 successes happen in 3 independent Bernoulli trials with probability of success equal to p equals 1 minus y. And that's 3 choose 2 times p squared times 1 minus p plus 3 choose 3 times p cubed. That's just a basic binomial distribution formula for 2 successes and for 3 successes. And that's 3 choose 2 times 1 minus y squared times y plus 1 minus y cubed. And after we multiply it out and calculate, this becomes 2y plus 1 times 1 minus y squared for y between 0 and 1, and s sub yc of y is 0 for y more than 1. Of course, yc is non-negative with probability 1, so we can use the Darth Vader rule to calculate the expected value. And therefore, the expected value of y sub c is the integral from 0 to 1 of 2y plus 1 times 1 minus y squared dy, which is the integral from 0 to 1 of 2y plus 1 times 1 minus 2y plus y squared dy. That's the integral from 0 to 1 of 2y plus 1 minus 4y squared minus 2y plus 2y cubed plus y squared. So it's the integral from 0 to 1 of 2y cubed minus 3y squared plus 1 dy. And that's 1/4 y to the 4th minus y cubed plus y evaluated from 0 to 1, so it's 1/2 minus 1 plus 1, and that's 1/2. And let us write y sub n for the system life under the new design. In this case, the survival function of y sub n is the survival function of the third-order statistic of a random sample of size 3 from the uniform distribution on the interval 0, 1, and therefore S sub yn of y is the probability that yn is greater than y, which is 1 minus the probability that yn is less than or equal to y, and for uniform distribution on 0 to 1, the cumulative distribution function is equal to y between 0 and 1, and therefore this is 1 minus y cubed, because the third-order statistic is less than or equal to some number if every single piece of the random sample is less than or equal to that random number. And so we simply have the cube of the cumulative distribution function of the uniform distribution on 0, 1. Of course, the survival function is 0 for y greater than or equal to 1, so this is another typo, my apologies. And therefore, the E of y sub n is equal to the integral from 0 to 1 of 1 minus y cubed dy. And that's y minus 1/4 y to the 4th evaluated from 0 to 1, so it's 3/4. Therefore, the improvement in expected system life is 3/4 minus 1/2, and that's 1/4, which is answer C. Please remember this is copyrighted material. The problem was created by me and the solution is mine. Good luck in your studies and good luck on the test.